guys, it is a Brick Caswell with another example recording. This is example 2 from section 1-5 in the SavvasRealize Algebra 1 textbook. In this example we are looking at solving an inequality with variables on both sides. So we are going to solve these inequalities and then we are going to be graphing the solutions. I always start with inequalities with drawing a river down the inequality symbol. Okay, so I'm going to solve this in the same way in which I would solve any equation. Alright, so we want to get the variable on one side and anything without a variable to the other side. And I usually prefer putting the variable here on the left hand side, and I'll show you why when I go to graph it. Alrighty, so first thing, I want to go ahead and move this 1.5x over to the other side. So in order to do so, I'm going to subtract it because it is currently positive on that side of the equation. And I'm a little nervous about these decimals, but you'll find that when I go to do this subtraction, that it'll get rid of that decimal, and that's a little less overwhelming. So when I do 3.5 minus 1.5, I get 2. So the expression turns into 2x plus 19 is greater than or equal to negative 7. And then the 19 doesn't have an x on it, so I'm going to go ahead and subtract it to the other side. I'm subtracting because it was being added. So I get 2x is greater than or equal to negative 26. And then right now, that 2 and that x, those are being multiplied together. So to undo multiplication, I'm going to go ahead and divide by 2. So I get that x is greater than or equal to negative 13. Alright, so that is the solution in terms of writing it out algebraically. So now we're going to go ahead and write the solution graphically. There's only one variable in this inequality, so I'm going to use a number line. I'm going to make sure that I have a couple of numbers around that negative 13. So my anchor point, my end point, is at negative 13. And I have to think about if I want to keep that circle open or if I want to fill it in. So remember, if your inequality symbol says that it can be equal to, you gotta shade that circle in. Alright, and then this says I need all the x values that are greater than that negative 13. So that means I'm going to be shading here to the right. So make sure to use nice big bold strokes so that your evaluator or your teacher can tell that it was shaded to the right. Now if you have a hard time remembering whether to shade right or left when you're thinking about greater than or less than, I actually use this inequality symbol to tell me. So if your variable's on the left, then you have an inequality symbol, then you have a number. It looks like the inequality symbol draws an arrow telling you which way to shade. But again, that's only if your variable's on the left. Let's try another one. So I'm going to start by drawing my little river. Oof, let's try to make that a little straighter, shall we? That was pretty bad. There we go. So I usually prefer, like I said, moving all my variables to the left. So I'm going to subtract this 5x to move them over. So 2x minus 5x is negative 3x minus 5 is less than negative 22. The 5 doesn't have an x on it, so I'm going to move it to the other side by adding 5, because addition's the opposite of subtraction. So I have negative 3x is less than, that's negative 17. Alright, and then this negative 3 is being multiplied to x. So to undo that multiplication, I'm going to divide by negative 3 using that inverse operation. Now remember, whenever you multiply or divide by a negative number, this inequality symbol flips directions. So instead of it being a less than symbol, it's going to turn into a greater than symbol. And a negative divided by a negative here will produce a positive 17/3. Alright, so I can't reduce that fraction. Now I can convert it to a decimal if I want, but it's going to be kind of an ugly decimal. It's 5.666666666 repeated. So I usually prefer keeping it in the fraction form. Alrighty, so now we're going to go ahead and graph it. So on my graph, I don't know, I can start at like 3 or something. Doesn't really matter as long as you have a couple of numbers around the 5. Alrighty, so 5.66666 is about right here, between the 5 and the 6. I have to decide whether I want the open circle or if I shade it in. So I look at my inequality symbol. It does not say that it's equal to, so I don't shade, I leave it open. And then it says it wants all the x values that are greater than that 5.6666. So I'm going to be shading to the right, like you see here. Alrighty, and that's example 2. So what to do when there's variables on both sides. Until next time.